So last day, if you remember, we practiced taking equations like, actually, let's do overall, right? We practice taking a system of equations, right? We practice taking a system of equations, right? Given something like this. And now scared, right? Plus y minus z is equal to 7, right? We looked at taking the matrix, taking the system of equations, write it in matrix form, right? And the first method was put it in matrix form. And after we put it in matrix form, right? The first method was to find the inverse of A and multiply it by B. The second method is where we augment A and B and we applied row reduction to echelon form, right? And then solve it from there. Okay? So today, we're just going to do back one more of this, and then I'm going to give you some rules. Like, for example, when you see 3 zeros augmented with the next zero, what does that mean? Or when you see 3 zeros augmented with a number, what does that mean? Or when you see something like this, what does that mean? Okay, so let's do one more echelon form. Let's make sure we could solve it, and then let's move on to those rules and wrap up, right? Adam call me or lucky man out. Or? And reinforcing, huh? The one from last day, was it 1 minus 1, 1 equal to 1? 1, 2, 4 is equal to 5. And all you can see, what was the last matrix I gave you? The last system of equations I gave you?
X minus y
equals 1. Okay, all right, yeah. All right, thanks.
How you apply this in real life?
Yes, well applicable. And the thing is like, if you have I'll give you an example. That's one. But matrices, if you have like real big sample sets, like 50, 60, 70 variables, put it in a matrix form and apply this. So matrices have real applications. Actually, some of the project you could probably even use this. Last year I gave my classes to do as a project. They collect scores. They collect like wins, losses, and draws, and they work out the table and see who plays first in Premier League and things. All right. So I would like you to solve this system of equations, please. Right? I want to use the row reduction method, right? Find the augmented matrix and then use row reduction. Adam, you're calling now? Oh, I didn't see it. X plus y minus z is 2, right? Right? I can show you Kramer's rule too, but I find it kind of long. Kramer's rules and next technique you can use to solve this. 1, 1 minus 1 augmented with 2. 2 minus 1, 1 augmented with 1. 3, 0, 2 augmented with 1. Right? So remember the order. You want to get 0 here, 0 here, then 0 here. Any answers online as yet? Right, so I'm going with row 1. I'm multiplying 2 by row 1, and I'm minus in row 2. Right, so 2 row 1 is 2, 2 minus 2 is 0. 2 minus minus 2 is 3. Minus 2 minus 1 is minus 3. 2 by 2 is 4. 4 minus 1 is 3. Anybody got that?
Yeah.
Yeah? Okay, nice. Now we're going to make a change with the row 2 now. All reach there? Andy didn't reach there. I'm giving you a little time, Andy. But you didn't tell me to get the last one. All right, finish it up, finish it up. I'm giving you some time. I'm giving you a few minutes, right? Try that quick.
We define it here. Again, x has 1, y has 1 2. C has minus 2 much. After you don't know. I will miss the minus.
Alright, let's check this out.
Is full of what's it again?
I'm not sure. Let's search one in a password. Alright, let's give it to you. Alright, so R2 will be equal to, I want to get it 0 in R2, so that'll be 3R2 minus 2R3. Right, so row 1 staying the same, and the last row staying the same, right? Right? So this is 0, minus 3, minus 0 is 0. Right? 3 by 1 is 3. 3 minus 4 is minus 1. And 3 minus 2 is positive 1. Okay? And then I'm going to row, I want to change row 1 now. So I'm just going to simply take row 1 and add it to row 2. Right? I'll leave in row 2 as it is. And row 3 as it is. So this will become 0, 0, minus 4, 4. So it means that minus 4z, it means that minus 4z is 4. So z is minus 1. Right? Then the next thing you'll see here is minus 3y minus z is equal to 1. We know that z is, oh wait, I got a fraction there. We know that z is, right, z is positive 1, so you will get y as 0. And then you have 3x plus 2z is 1. So x is equal to 1. Z, why I put z there?
If I get x as 1, right?
Yeah. Provided some of your home point where it might be right. Right, but if you went from here to here and wrong, then you will get 0. Okay? You're okay with that? So that's the way you apply row reduction. What I want to show you here, I'm going to give you some rules in a little while. What I want to show you here, whenever you get a row looking like this, or even a row looking like this, you will have a unique solution. It means that z will have one particular value, y and x will have one particular value. Okay? So if you have a number in the row equal to a number after the augmented part, then it means that you're going to get a unique solution. But what would happen if you had 0, 0, 0, giving you 0? No. How much solutions you have here? 0x plus 0y plus 0, 0 plus 0, z is 0. Think about it. Put values x, y, and z in there and see if you get 0. Infinite number of values, right? You realize that? You can put anything for x, y, and z and get 0. So those are called infinite solutions, right? So if you get 4 zeros, that's infinite solutions. But suppose you get 0, 0, 1 giving you, 3 zeros giving you 1. That makes sense, right? Right? That's not possible, right? So this has no solution. So based on just knowing those 3 conditions, you can figure out the number of solutions it has. Okay? So if it has an infinite number of solutions, then one of the rows will have 4 zeros. If there is a unique solution, then you might end up with something like this, or even like this. But if you have no solution, then you will get something looking like that. 3 zeros equal to 1. All right? Just want to give you a little note on that, right? Any questions online?
No, sir.
All right, so when solving, system of equations, if I recorded, yeah, you're not paying attention. Who asked you? Right, if you have a complete row of zeros, right, 1, 2, 3 zeros, a complete row of zeros. This is an infinite number of solutions. This is unique solution. This is no solution. Right, this is said to be inconsistent. Of course, the next two will be consistent, right? If they end up with 3 zeros equals to k, that's inconsistent. All right, so I want to give you an example, and I want you to tell me, of course, you will have to do row reduction for a couple, like 2 or 3 lines of row reduction, right? I want you to tell me how many solutions that this matrix have. I'm giving you the augmented one time, right? Anybody writing online? I giving you the augment. No? Okay. I giving you the augmented one time. You don't take it already, greedy man. I don't have no blue waters. but I will have something in it, so I put a tablet and it to stay away. Take it already? You can take it, but you just stay away. No, look at that small hole in the corner there. Actually, I'll give you the equation. 3x plus 2y plus z is equal to 4. 2x plus y minus 3z is 2. 7x plus 4y minus 5z is 8. Right? All I want you to do is to determine the number of solutions it have. Right? And then I will show you how to write an infinite solution.
I get the 1 0 0. Just fine. And it's so far, I get really single week. I think mine is.
Are you all got y'all didn't message online? Okay. So the augmented, how much you got? Right. But we have to learn to represent that. We have to learn to still find a way to write it as an answer. Like what is X, what is Y, and what is Z. Right? I want to show you how to write that, right? So we take in row 1, 2 row 1 minus 3 row 2. So that's 2, 1 minus 3, 2, 7, 4 minus 5, 8. 2 by 3 is 6 minus 6 is 0. 2 by 2 is 4, 4 minus 3 is 1. 2 by 1 is 2, plus 9 is 11. All together. 2 by 4 is 8. 8 minus 6 is 2. You got that? No?
We have minus 2 minus 3. Oh, yeah, I got it.
I'll surely get that, right? Oh, you will get at the same time. Okay. R2. Okay. R2. R2 with R3, right? So that'll be 7 R2 minus 2 R3. So 0, 1, 11, 2, 7, 4, minus 5, 8. 7 by 2 is 14, minus 14 is 0. 7 by 1 is 7, minus 8 is minus 1. 7 that is minus 21 plus 10 is minus 11. And if I had to guess, it's minus 2. Yeah? And now, if I take row 2, let's change row 1, it don't matter, right? Row 1 is equal to row 1 plus row 2. So I'll leave in these two as the same. So what you're going to get here, on top, you'll get 0, then a 0, then a 0, then a 0. So it's an infinite number of solutions. But there's a way for you to represent this infinite number of solutions, right? So watch this here. So if you have minus, looking at this second row, minus y minus 11z is minus 2. You see that? So it means that y, is equal to 11z minus 2. All okay with that? Yeah? 11z minus 2. So if I were to let some constant, right? If I were to let some constant equal to z, what that's all on the pick? Lambda. Let lambda equal to z. I have y is equal to 11 lambda minus 2. Okay? And now we have 7x plus 4y. Y is 11 lambda minus.
Minus y equals 11z equals minus 2.
Sorry?
Y equals 11z minus 2.
Right.
Minus y equals 2. And plus 2.
Yeah. I'll be back to that. But as y is supposed to be equal to 2 minus 11z. That's what I meant, right? Yeah. Right? So y is equal. No, I just introduced that. I said let z equal to lambda. So y is equal to 11 lambda. Okay? So just one variable I introduced. All right? So what does that mean? We know what y is and we know what z is, right? So wherever lambda is, just put lambda into y. Now you have 7x is equal to 8 minus in fact, let me not leave out anything. So 7x plus 4y minus 5z is equal to 8. Okay? 7x plus 4y minus 5z is equal to 8. And all I have to do now is make x the subject of the formula. Can I change? Actually, I'm going to rub off from top here, right? Right, so I'll get 7x plus 4y. Y is equal to 2 minus 11 lambda minus 5z. Remember, z is lambda is equal to 8. So I get in 7x plus 8 minus 44 lambda minus 5 lambda is 8. So 7x is equal to carry across the 8 that looks like it's canceling off, and I get in 49 lambda. So x is equal to 7 lambda. Anybody got that? Anybody multiply it out? Just check and see for me now. So anyway, let's pretend that that's correct. We know what x is, we know what y is, and we know what z is. Right? So we write in x, y, z is equal to 7 lambda. Y is 2 minus 11 lambda, and z is equal to lambda. Hey, keep this by you there. We have to be careful. Shake it up and make sure it's still, if it's not soluble or not. Sometimes it do this, if I put too much, it does. Check it and just shake it up. Hey, do something else too, but I can't tell you what. Huh? Anybody else get out? Just multiply it out. 7x plus 4y. Yeah, well, that's 6, so I'll take it to stay awake. All right. So this is the way you represent an infinite number of solutions. Man, take my water and drink it. You that bad man, boy? Huh? I'll tell you again. You asked me if I had one, I'll tell you what I thought I had one. All right, so that's the way you represent your answer, right? I'm going jail in on the edge. Okay. So let's take a look at this version here now. Any questions online?
No, sir.
Okay. So that's basically how you handle it, right? One thing I didn't show you as yet, I can probably show you later on, is that if I ask you to find the inverse of this, we could use the row reduction method. All we have to do is convert this matrix into this matrix. Use row reduction to make this matrix look like this. So when you finish, the left-hand side will look like this. And your right-hand side will be an inverse. Right? It's the next technique of finding an inverse, but we're alone. Are you okay with that? So that I'll show you one, I'll probably show you an example later on, right? All right, so if you look at 2013, there's a question that, here's what they gave us, right? Instead of taking a picture, I will just show you what they gave us. They gave us a matrix 1, minus 5, 1, 1, 1, minus 5, minus 1, 1, 3, augmented with 1, 2, 3. So they wanted to reduce it and determine whether or not it's consistent. Right? So you're just checking to see if it's consistent or not. And then that was part one, right? They want you to determine if consistent. And they said to replace the third row, replace the third row with 1, minus 5, 5, 3. And determine whether the solution is unique. Determine if unique. Try that, please. So the question was worded a little bit different. They don't want you to solve it. All they want you to do is take the first augmented matrix and determine if it is consistent or not. That's all. Right? That's all you're telling them. It is consistent or it's not consistent. Shabara. Right? And the last thing, part 2, take off row 3 and write 1 minus 5, 5, 3. And determine if it's unique. Don't solve it. Just tell them if it's unique or not and why. Okay? Copy it down. It says 2013. What are you not sure about? Huh? You're replacing row 3. That's part 2, eh? Part 2, you're replacing row 3 with 1 minus 5, 5, 3. After you finish part 1. No. You're doing about the whole thing. After you do part 1 and you determine if consistent or consistent, say the same thing twice. You go back to matrix A and take off the last one. Not the row reduced one. Yeah. You're taking off this. Okay. Oh yeah. Sometimes it work in reverse. I find it slowing down a little more. Working in reverse. Working in reverse. What do they mean by consistent? Right, remember, Remember, if you end up with 3 zeros and a number, it's inconsistent. So if the last one inconsistent and the top two consistent, right? I think I wrote that somewhere here. Sorry. This one, I didn't write it. I thought right here. So C inconsistent, but these two here consistent. All right. Oh yeah, try this, please. Oh yeah. No, I want water. Huh? No, I want small one. Some. Nanti ayat na ay. Yeah, how it worked out. Did you do anything? So you got not consistent, huh? Or inconsistent? Ooh, touchy, touchy. So what I'm making a fish, so it's tablet making a wave. Right, I will row one minus row 3. Right, you don't always have to use row 2. So I am getting 1 minus 1 is 0, minus 6, minus 4, minus 2, minus 2. Pim, pim, right, to change row 2 now, I am taking the old row 2 and adding it to 5 row 3. So that's minus 5. What's that? Minus 5 plus 5, that's 0. Minus, sorry, 1 minus 25 by, yeah, by. 1 minus 25 is minus 24. 1 minus 15. Right? 1 plus 15 is 16. Anybody get that? Right? And then minus 2 plus 10 is 8.
It's 7.
Boom, 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 boom. Boom, 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 boom. I guess 7. Hold on, I don't know why I feel like my sign's wrong. I feel like I'm watching the wrong thing, right? So that's 0 there. 1 minus 25 is minus 24. 1 plus 15 is 16. And then minus 2 plus 10. That's not, hold on, I feel like my sign's wrong. Huh? Sign's looking wrong? Yeah, I feel like minus 6 supposed to be something else. On top. Oh, yes, yes, yes. This is supposed to be plus 6 here. This is plus 24. Thanks, Rana. Right? So now if I try to take row 1 and I multiply row 1 by 4, row 1 by 4, and I add it, sorry. Right. So I taken 4 by row 1, 4 by row 1, and I adding it to row 2. That's it. I should get so instead I should get 0, 0, 0. 4 by minus 2 is minus 8.
I get 45.
Right? So when it add it up now again, 0, 0, 0, minus 8 plus 17 is 9. Anybody get that? 0, 0, 0, 9?
I get 45.
Right? Okay. So therefore I got 3 zeros and a 9, so therefore it's inconsistent. All okay with that? Therefore it's inconsistent.
Yeah, I get it.
And now we have to determine if it ever unique. So you don't have to work out anything, right? Take a picture or screenshot it fast. I just want to do it over now with the last value, with the last row. So now we just do it over fast. 1, 1, minus 1, 1, 2, 3, minus 5, 1, 1, 1 minus 5, 5, right? We're doing the same thing again. I want to get row 1 to get 0. So that will be row, that'll be the O row 1 added, sorry, minus. And I'm making a mistake. Right? So that is minus 5, 1, 1 minus 5, 1, 5, 2, 3. Right? So I should get back the same old values, right? Right? 0, positive 6, negative 6, negative 6 now, right? Minus 1, minus 5, and then 1 minus 3 is minus 2. Okay? And then you want to get 0 in the next one. You want to get a 0 in row 2. So I'm taking the old row 2 and add it to 5 row 3. So this is 0, 6, minus 6, minus 2, 1, minus 5, 5, 3. So when I multiply this out, I'll get 0 here, of course. Then I will get 1 minus 25 minus 24. And I'll get 1 plus 25, which is 26. Then I will get 2 plus 15 is 70. Anybody get that? Yeah? And then I want to get a 0 in row. I want to get 0 in row 1 again. Right? A 0 in row 1, which might look something like this, right? A 0 in row 1, so I'll leave, sorry. A 0 in row 1, which means row 2. Row 1 would be I take in row 1, multiplying it by 4, and add it to row 2. Right, so that's 0 minus 24, 26. Right, so this is 0. 4 by 6 is 24. 4 by 6 is 24. 24 plus 24 is 0. 4 by minus 6 minus 24 plus 26 minus 24 plus 26 is 2. And then minus 8 plus 17 is 9. Anybody get that? Yeah? So since we have 2 zeros at 2 and a 9, solution is unique. Okay? I'm not bothering to show you Cramer's rule, but Cramer's rule is a technique that they use to solve these equations, right? But I'll do a video and I'll just share it and you can take a look at it, right? It's not really a technique you need to find. But what Cramer's rule is is make you find, to take 4 different matrices and find the determinant 4 times. And then plug it into a nice little formula. That part easy, but finding the determinant kind of long. Right? Remember, as I told you before, echelon form. Echelon form in textbooks will look like this. They have 1s in the diagonal, and instead of getting the 3 zeros on top, they get below. And then will here's be any random thing, A, B, C, or anything you want. Right? So you could get your echelon form like this, get your 0 here, then here, then here, and then divide each one to get the diagonal 1. Right? That's an option if you want. But that is not necessary when you need to solve, right? So you could follow that version, but even if you do it like this, this is also an echelon form that allows you to solve. All right. Just one thing I want to show you. Probably let you try it. How to find the inverse using row reduction. Right? How to find the inverse using row reduction. So what you have, so let's say given something like this. Let's see, we could find one here. Right? Let's say I gave you something like this. 2, 1, 2, 1, 0, minus 1, 3, 1, 4. Augmented with 1, 0, 0, 0, 1, 0, 0, 1. Right? How do you perform row reduction to find the inverse? So let's call this A. Right? So in order for you to do it, you have to apply row reduction. Right? To replace A and D with I. So if I replace A with I, how the final matrix will look, Andy? Yeah, Andy, you ain't paying attention, and now I ask you, and now you're gonna be in problem. Huh? So your final matrix will look like this. Here's I and here's A. Okay? So your original matrix look like this. When you apply row reduction, it looks like that. Right. Quick question though. What is the order for getting the zeros? So you can figure that out now. What is the order for getting the zeros? You can't just randomly find zeros everywhere. So remember, you want to get 1 here, 1 here, 1 here. That easy, right? You could do that last, right? Because that's just to divide. But where do you target first? I'll start you up here. If you target here first as your first zero, where you'll get your next zero? Remember, it has to look like this, right? Where do you think is a good spot to get the next zero? To the right, underneath, to the left, on top? On top is a 1. Underneath. It's always good to get them on each other. Where do you think is a good spot to get the next one? To the right. Right? Good. Where are you going next? Right, directly above. Then here and here. Right? Just be careful that you don't bring back a 0. Okay? So that's the order. Right now, do you think? Last thing. That's the last thing we do. I wouldn't even touch problems today. I'll do that first thing when school opens. Right? Because you have a 0 in row 2, you can probably switch. Remember, you could do that, right? So you can switch around row 1 and 2 or row 2 and 3. So you already have a 0 there now. So you can start here instead. And I'll see a 0 there. So you can put 1, 0, minus 1 on top. Switch it with 2, 1, 2. And you already have 3, 1, 4. So you can do something like that. You can even split columns, right? Doesn't make a difference. Actually, the columns just change a little bit. But that's basically how you can start. So you already have a 0 on top. right? So target is 0 in row 2 and 3. Right, you already have the fourth 0, right? So the third 0 you're going after. Quick question. Which 2 rows are going to use to get the 0 in the third row? Which 2 rows are going to use? You want to get a 0 here. So what are you going to use? Row 2 and 3. Right? You can't use row 1 because this 1 will bring back a value here and mess it up. Okay? That's something for you to remember. Right? Go ahead. So you have 2 more zeros again, and you're done. 3 more zeros, sorry. Right? How it look?
I get 126.
So your final answer should be, you can factor out the 1/3, right? And you'll get -1, 2, 1, 7 minus 2, -4, -1, -1, 1. That's the answer. So the final answer, when you're done, will look like that. Anybody reach here? Huh? Oh, you're not done. Anybody get that one line? Right? So when you finish and you factor out the 1/3, that's the way it will look.